How does anything actually get from point A to point B? Seems like a simple question, right? But in physics, you get a few different and honestly kind of contradictory answers. Sometimes we see light acting like a wave, spreading out everywhere. Other times, it acts like a particle, zipping along the single fastest path. So, what's the deal? Are these just competing laws of nature?
That is the big puzzle we're digging into here. We've got waves like ripples in a pond, we've got straight-line paths, and then there's this third, much weirder idea called action. It really feels like these should be three totally different rule books for how the universe works. But what if they're not? What if there's a deeper connection? Well, it turns out there just might be. Check out this diagram. It's making a really bold claim that waves and paths and action, they aren't separate laws at all. It's suggesting they're just different ways of looking at the very same fundamental process. So let's dive in and really unpack what this image is telling us. All right, first up, let's talk about the wave. I want you to think of this as the realm of what could happen, the field of pure possibility. Now, the name sounds complicated, I know, but the idea itself is actually pretty beautiful. Just imagine dropping a pebble into a perfectly still pond. That ripple that spreads out, that's your wavefront. Huygens Principle just says that every single point on that ripple is busy creating its own tiny new ripple. And all those little baby ripples add up to form the next big one. It's like this amazing cascade of expanding possibility.
And you can see that exact idea playing out right here in our diagram. See those concentric circles? The ones labeled t equals 1, t equals 2, t equals 3, that's it. That's the wave of possibility just expanding outward from a single point, a growing sphere of all the potential futures for a single particle of light.
Okay, so if the wave represents everything that could happen, what about what actually does happen? Well, that brings us to our second concept, the path.
This one probably feels a lot more intuitive, right? Nature is efficient. It's almost lazy in a good way. If light needs to get from point A to point B, it doesn't wander around. No, it takes the absolute fastest route it possibly can. It's the ultimate natural shortcut. And if we look back at our diagram, you see those straight lines labeled light ray? That's exactly it. The waves, they represent all the possible places the light could go. But the ray? That's the one single actual path the light takes. It's like reality just cutting a straight line right through a field of pure possibility. So we've got the wave of what if and the path of what is. But how does nature pick one over all the others? That brings us to our final and, most abstract piece of this whole puzzle, the principle of least action. The best way to think about action is like it's the universe's own form of currency. Every possible journey, every path, has a cost, and that cost is a mix of the energy it takes and the time it uses. This principle just says that nature is incredibly thrifty. It always chooses the path with the lowest total cost. It's always looking for the best bargain. And here is the absolute crucial point. Let's look at how this shows up on our diagram. See the labels that say action, s equals 1, s equals 2, s equals 3? Do you notice something incredible? They line up perfectly with the wavefronts at time equals 1, 2, and 3. The expanding wave of possibility and the accumulating cost of action. They're actually the same thing. Okay, so we've got our three concepts on the table. Now for the fun part. Let's snap them all together and see the magic happen. This is it. The core idea, boiled down to its simplest form. You have the expanding wave, which is this whole cloud of possibilities. You have the straight path, which is the one actuality that gets chosen. And the point where they meet? That, my friends, is a real physical event happening in the universe. And that quote on the slide, man, that really hits the nail on the head. This isn't about different theories fighting it out. It's a description of a single process, causality itself, just viewed from three different perspectives: the perspective of time, the perspective of space, and the perspective of action. Okay, look really closely at the diagram with me now. See those points where the straight light rays cross the curved wavefronts? Right there, at those intersections, everything lines up. The wave, the path, and the action all coincide. The diagram calls this a causal update. It's the precise physical moment when one of those infinite possibilities becomes a single concrete reality. So let's just break that down one more time, step by step. First, a wave of pure possibility expands out from an event. Second, nature somehow selects the single most efficient path, the one with the least action, through that wave. And third, where that path crosses the wave, bam, that's the next event. That's your causal update, where one of those infinite potentials collapses into a single, concrete moment in reality.
So, what's the big takeaway here? Why does this even matter? Well, this unified picture doesn't just tidy up a little physics puzzle, it might completely change how we think about the flow of time itself.
What this picture is telling us is that causality isn't some smooth, continuous river. It's more like a series of distinct, separate events, these causal updates. Reality doesn't just flow, it ticks. And each one of those ticks is one possibility collapsing into one actuality, happening in these tiny, discrete quantum steps.
And that leaves us with a really fascinating and kind of mind-blowing question to chew on. If reality really unfolds in these little ticks, is time itself quantized? Is that smooth, flowing river of time that you and I feel every day just an illusion, built from a rapid-fire series of individual causal snapshots? Definitely something to think about.